Hello, good day to my viewers. Today we will be tackling trigonometry. Um, in fact, this time we will learn about the angle of elevation using the trigonometric functions. Okay, we have an example here that says the angle of elevation of a hot air balloon climbing vertically changes from 30 degrees at 2 p.m. to 60 degrees at 3 p.m. So the point of observation of the angle of elevation is situated 400 meters away from the takeoff. What is the upward speed as shown constant of the balloon? Okay, so let's very quickly solve this problem. First is we can cut the solution into pieces. Okay, we will try to solve this in stages. So first, let's solve first for the value of the h1 or the first height. Okay, so from that, using what we've learned, no, from the from Sokatoa, we will be using tangent here. Why? Because we will be um, taking advantage of the given. Okay, because tangent, when dealing with tangent, you will be using the opposite side of the angle and the adjacent side. Okay, so in this case, we will be using this function tangent. All right, 30, because that's our angle here, is equals to the opposite side. What's the opposite side? In this case, that's h1, which happens to be our variable, over adjacent side. The adjacent side is 400. Okay, so to solve for h1, we will just try actually to multiply or cross multiply 400 to the other side. Or in other words, we can also multiply both sides by 400. Either way, whichever is comfortable with you. So that you can cancel this one out. Then all you have left is actually 400 tangent of 30. That's your h1. Now, if you'll try to get the value of tangent 30, okay, let's try. Tangent of 30, that's 0.577. So that's 400 times 0.577 is equals to h1. So your h1 now becomes 450, 400, so 200. You now have 200.9 meters. That's your h1. Okay. Okay, so we have now solved already for the h1, the first height. Okay. So the next thing is we will now try to solve for the bigger triangle. This one, the entire one. Because we will be utilizing this triangle because this is a right triangle, which is then much easier for us to use the trigonometric function. But then this time, your angle changes na. Instead of 30, this time it becomes 60 because, see, looking from the figure, the bigger triangle now has an angle of 60 degrees. So this becomes 60 is equals to, okay, if we will be using the tangent function, it is now equivalent then to the opposite side. Opposite side. This time, it's instead of just h1, this time it's the whole thing. So we will call that one the big H. Okay, all over this distance, 400. So that's 400 meters. Okay. Basically, we will be doing almost the same thing. We will multiply, cross multiply, or multiply both sides by 400. So that we can cancel this 400 out. All you have left is H, so that we can solve for that big H. and then 400 tangent 60. Okay, so once again, let's solve for the tangent of 60, which is 1.73. So that's 400, 1.73 equals to h. Okay, multiply that by 400. So you have now 692 meters. Okay, so we now have solved for the smaller height, and then we have solved for the entire height. No? But the question here actually is we will have to solve for um, the speed of the balloon. And what we are given here is the time it took from this point to this point. That one. And in this case, the vertical height it took is what we call now the h2. So therefore, let's solve for the second height, this one, the h2. Since we already have solved for the big H and we already have h1, so definitely we can also already solve for h2. As we can see from the equation, we can say that big H is equals to h1 plus h2, right? So to solve for h2, we can just transpose h1 to the other side. So h, the big H is 692. Transpose the h1 here. This becomes minus. H1 is 230.9 is equals to h2. We already have h2. So by subtracting 692 minus 230.9, what do you get? You get 461.1 meters. All right. So we already have that height. The question is speed. So what is the formula for speed? Speed is actually equals to distance traveled over the time it took to travel that distance. So that's distance over time. So what is this distance we're talking about? Since we're given here, it took now 3 minutes from 2 p.m. to 2:03 p.m. to get from this point to that point. So the distance actually talks about the h2, which we have solved, okay, from here. So this is now 461.1 meters per, okay. It says here, it took what? 3 minutes. So 3 minutes, that's around, okay, 3 minutes. All right, so that's the speed. So the speed of the balloon, okay, let's try to divide that. 461.1 divided by 3. So you get 153.7 meters per minute. Okay. So that's our ultimate solution. Okay. So I hope I was able to explain it clearly. And if you need lessons that goes along these key points, then just please drop in your comments below so I could give you another more examples. Okay, bye.